Okay, students, so let's get started with the first chapter MCQs for AS level physics, that is physical quantities and measurement techniques. So let's start with it. Okay, so the first few MCQs, let me give you a brief overview before starting. The first few MCQs are from the topic of estimations. These are some quantities, some values that you must memorize in the examinations. Before going to the examination, these are some quantities or values that you must memorize. How will you know which quantities do you have to memorize? I have created a Word document here that I have attached with the Google Drive ka link in the description below. You can download it. And these are your things that you need to memorize. Perfect. Let's move ahead. And one more thing, that the answers to this PDF are in the description below as well. Okay? The answers are on the back side. Here are the answers. So once you go to the literal bottom of this PDF, you will get the answers as well. And this PDF is attached in the link in the description. Let's continue with the you can say questions. A student estimates the maximum speed of some different moving objects. Which maximum speed is not a reasonable estimate? Which maximum speed is not a reasonable estimate? If you come to this value B, you can see that the estimate that the student is saying for an Olympic sprinter is 0.1 kilometers per second. If you analyze 0.1 kilometers per second is what? It is 100 meters per second. This means an Olympic sprinter can run 100 meters in 1 second. And if you have been a little up to date with the news, you might know that the record for 100-meter dash is 9.56 seconds, I guess, and that is held by Usain Bolt. So this is an incorrect assumption. B is your answer. I have also placed these speeds here in the estimation document. Can you see container has an average speed of 10 ms minus 1? Racing car has an average speed of 90 ms minus 1. The snail has a speed of this. And obviously, Olympic athlete has a speed of 10 ms minus 1. Let's further move ahead to the next question. The answer to 1 is B. What is a reasonable estimate of the cross-sectional area of the wire in paperclip? Okay, we have to calculate the cross-sectional area of the wire in paperclip. Okay. Now, let's again go to the estimation worksheet. Can we see the diameter of a paperclip written here? Yep. Can we see the diameter of the paperclip written here? Yes. And we know that paperclip has a cross-sectional area of a circle. Can I calculate the cross-sectional area? Yes. Area is equals to pi d square over 4. Area is equals to pi. What was the diameter? 1 millimeter. 1 into 10 is the power of minus 3 whole square divided by 4. Let's calculate this. I think the answer should be 2 square into pi divided by 4. This comes out to be 7.8. 7.85 into 10 raised to the power of minus 7 meter square. Any similar answers here? Yes, C is your answer. So by switching between the estimation worksheet or the estimation document and the MCQ worksheet, you can answer all these questions. I have made sure that all the estimation values that have come in the last 20 years are in the document. So you can refer to it. Let's move ahead. What is the best estimate of the wavelength of green light? B, 54 nanometer, 540 nanometer. I have also written this in the document. A stone sinks in water. What is a possible value for the density of the stone? Now, this is something conceptual. See, density of water is what? Density of water is 1000 kg ms minus 3. Anything having a greater density than water will sink inside water. If you analyze option A, 800, this is not greater than 1000. If you analyze B, 200, yes, this is greater than the density of water. B can be my answer. And C and D will not be your answers because the units are wrong there. Simple. The B is my answer because the density here is greater than the density of water. Hence, the stone will sink into the ground, into the beaker. Simple. What is the best estimate of the number of atoms in a piece of metal of volume 50 cm cube? Okay, so let's again go to the worksheet. Let's again go to the estimation worksheet. Can you see any helpful thing here? Yes. Volume of one atom is 1 into 10 raised to the power of minus 24. Volume of one atom is 1 into 10 raised to the power of minus 24. So what will be the number of atoms in 50 cm cube? Very easy. 1 into 10 raised to the power of minus 24 cm cube is the volume of one atom. So 50 cm cube will have how many atoms? Let's place an X here. Cross multiply 50 divided by 1 into 10 raised to the power of minus 24. This comes out to be 5 into 10 raised to the power of 25 number of atoms. B is your answer. Let's further move ahead. Which estimate is reasonable? Which estimate is reasonable? 1 into 10 raised to the power minus 3 kg for the mass of grain of sand? No. 1 into 10 raised to the power minus 2 meter square for the volume of tennis ball? No. 1 joule, this 10 raised to the power of 0 is basically 1. 1 multiplied by 1 will give you 1 joule of work done for lifting an apple from waist height to head height. Yes, C is your answer. This is also written in the estimation document. Where is it written? 1 second, I wrote it. Yeah. Work done to lift an apple from waist height to head height is 1 joule. So everything is written in the estimation document. You just have to refer back and forth. What is a reasonable estimate for the volume of an adult person? What should be the reasonable estimate for the volume of an adult person? 0.1 meter cube. Simple. Let's further move ahead. What is the reasonable estimate for the kinetic energy of an Olympic athlete sprinting in a 100-meter race? So, what will be the estimated, you can say, velocity of an athlete? 10 ms minus 1. What is the mass of an athlete? Let's say 80 kg. Can you calculate the kinetic energy? 1 upon 2 into mass, that is 80, into velocity, that is 10 cow square. 140 40 into 100. This gives you answer as 4000 joules is your answer. C is your answer. What is a reasonable estimate for the volume of a fully inflated standard football? 600 cm cube? No. 6000 cm cube? Yes, this seems reasonable. A football seems to be have a volume of 6000 cm cube. Although these MCQs are pretty nonsense, but you have to deal with them. You have to deal with them logically. C and D cannot be your options because they are too large. Okay, let's now start with the topic of physical quantities. Estimation has been done. All the documents and all the things are in the description below. Which row shows a physical quantity and its base unit in the SI system? Okay. Current and ampere. Yes, this can be my possible option. Yep. Force is not a base unit. Mass is a base unit, but the SI unit shown is not correct. Temperature is also a base quantity, but the SI unit is not correct. A is your answer. Let's further move ahead. Okay, an object of mass m is suspended by a spring from a fixed point. Okay, the spring has a spring constant k. Perfect. The object is set into vertical oscillations of period t. Which equation for t is homogeneous with respect to the base units? Okay, let's see. So, what are the base units of t? Seconds. 2 pi is a constant, so we will ignore that. What will be the base units of K? That is the spring constant. Pretty easy to calculate. Force divided by extension is equals to K. What are the base units of force? Kg. Ms minus 2. Simple. And divided by what? Extension, that is meters. So meters and meters gets cancelled out. The unit of K come out to be what? Kg second minus 2. Perfect. Please remember this. Okay, so here you have K units as kg, S minus 2, and in place of mass you have kg. Kg and kg cut out, second is equals to S minus 2. This is not your correct option. Let's check out B. In B, your units of seconds will be S. 2 pi will get ignored. Mass has a units of kg. What are the units of K? We have just calculated. Kg, S minus 2. Kg cancel out. S minus 2 comes to the top side. S square is your answer. S is not equals to S square. B will not be your answer as well. Let's try out option D. S is your units for second, 2 pi gets ignored. Mass is kg divided by what is your K? K is kg. S minus 2. Kg cancel out. S minus 2 comes to the top side. Here you have an under root. Under root of anything square causes the square power to cancel out. D is your answer here. Now you can check your answers on the back side as well. Can you see this number? This is the question number. This is the question number. So if I go to the back side, let me see what is the answer for 23. The answer for 23 is D. Simple document. You just have to utilize it correctly. Let's further move ahead to the next question. Let's see this. Which quantity is an SI base quantity? SI base quantities are the 7 quantities which I have told you about in the first lecture. Not force, not Newton, not time, not second, and time is your answer. Why? Why not second, sir? Because second was the SI base unit. There is a difference between SI base unit and SI base quantities. SI base quantities were time, mass, temperature, current, things like this. SI base units were what? Seconds, kilograms, ampere, Kelvin, things like these. So you have to differentiate here. This is SI base quantity. You can also check on the back. 24 should have an answer of D. One second. 24 has an answer of D. Yes, we are correct. Let's further move ahead. What is not an SI base unit? Okay, what is now we are talking about SI base units. Kilograms is an SI base unit, ampere is an SI base unit, second is an SI base unit. C, coulombs is not an SI base unit, so this will be your answer. Let's further move ahead. There is a difference between SI base units and SI base quantities. If you are a good student, you will remember it. The relationship between D and T is given by this equation where B and C are constants. Okay. The units of D is meter square and the unit of time is seconds. Perfect. What are the SI units of B and C? We have to calculate the SI units of B and C. How will we do that? If you see 1 over T is what? 1 over T is equals to second minus 1 units. The units of 1 over T are what? Okay. The units of 1 over T are what? Second minus 1. Simple as that. Okay, one thing gets cleared out. The units of 1 over T are second minus 1. Perfect. Now, if this equation is correct, the units of 1 over T will be homogeneous with B over under root D, and they will also be homogeneous with C. So first of all, let's compare 1 over T with C. 1 over T are the units of what? Second minus 1. C will have a units of what? Second minus 1. So option A and C will get cancelled out. Okay, let's compare 1 over T now to B under root D. 1 over T is what? Second minus 1. B is what? We don't know. D is what? Meter square. So place it here. Meter square. This gets cancelled out. MS minus 1 is your units of B. Any answers like that? Any answers like that? B is your answer. You can also easily check 26 ka answer should be B. Let's check it out. 26 answer is B. Simple. Let's further move ahead. Okay, what is ohm represented in SI base units? So we have to calculate the SI base units of ohms. Very easy. Do you remember that ohms was something like this? Voltage over current is equals to resistance. We will utilize this formula. But before that, we need the units of voltage V. How can we calculate the units of V? We remember voltage used to be equal to work done over charge. What are the units of work done? Work done units are kg, m2, S minus 2. The units for work done are the same as the units for energy. What are the units of charge? Ampere into seconds. Can I rearrange this equation? Yes, kg m2 s minus 3 a minus 1 are your units for voltage. Substitute your units here. kg m2 s minus 3 a minus 1 divided by what are the units of currents? Ampere is equals to R. kg, let's take ampere to the top side. M2 s minus 3 ampere minus 2 are your units of resistance. Is there any option like that? A is your answer. This is a bit lengthy question, so let's see, confirm it. 27's answer is A. Perfect. We are going incredibly good. Chalo, let's move on to the next question. The drag coefficient CD is a number with no units. It is used to compare the drag on coefficient, drag on different cars at different speeds. CD is given by this equation. Okay, so this is the equation of CD, where F is the drag force on the car, rho is the density of the air, A is the cross sectional area of the car, and V is the speed of the car. Perfect, perfect. What is the value of N? So, first of all, let's analyze. This CD has no units. Okay, so first of all, let's write this equation. CD is equals to 2F VN rho area. Okay. If CD has no units, it will also get ignored in the calculation of units. And 2 is a constant. It will also get ignored in the calculation of units. So your final equation to calculate units will be something like this. Velocity power n into density into area is equals to force. I have taken these to the left side. This 2 has been ignored. CD has also been ignored. What are the units of velocity? ms minus 1 power n. What are the units of density? kg m minus 3. What are the units of area? M square. What are the units of force? kg ms minus 2. Is anything getting cancelled out? Yes, kg and kg gets cancelled out. Okay. Here if you look closely, ms minus 1 power n. This is meter minus 3. This is meter plus 2. This will become what? Meter minus 1. Simple as that, is equals to ms minus 2. Okay. Now what can you do here? Very, very easy. You can say that m power n, s power minus n, m power minus 1 is equals to ms minus 2. Okay, let's sum up the bases. Mn minus 1 s minus n is equals to ms minus 2. Compare either of the coefficients, you will get the same answer. If you compare n minus 1 to here m, if let's say we are comparing m, if let's say we are comparing m, mn minus 1 is equals to m. If there is no power, there is 1. N minus 1 is equals to 1. N is equals to 2. However, if you are comparing S, then 2 you will get the same answer. S minus N is equals to S minus 2. Minus N is equals to minus 2. N is equals to 2. What is your answer here? Your answer will be B. Simple as that. Let's further move ahead. Let's see this. The mobility of electrons traveling through a metal conductor can be calculated using this equation where E is the charge on the electron and M is its mass. The average time between the collision with the electron in the metal is T. Okay. So this last statement is really important. E is the charge on electron, M is the mass. The average time of the collision of the electron is this. Calculate the SI base units of mu, the constant. Okay, very easy. Mu is equals to what? E is your charge. Okay, so it will have a unit of what? Ampere into seconds. Always remember charge Q as the formula of what? Current into time. What are the SI base units of current? Ampere. What are the SI base units of time? Seconds. Divided by the mass, that is kg, into time, that is seconds. Okay, so what will your final answer become? Kg minus 1 as square. Any answers like this? B is your answer. Let's also verify our answer for 31. Your answer should be B. Yep, for 31, my answer is B. Perfect. Let's further move ahead. Okay, let's see this. The luminosity of a star is given by this. Okay, so this is the equation for the luminosity of the star. R is the radius of the star. T is the temperature of the star. And phi is a constant with units this. You have to calculate the SI base units of L. Pretty easy. Easy peasy question. L is equals to what? You will ignore 4 pi since it's a constant. R square phi t power 4. What is R? Radius. What will be the SI base units? Meter square. What are the units of phi? Now in phi, you will notice an interesting thing here. The units are not already in SI base units. The units of phi are what? Volts. M minus 2, K minus 4. Although meter minus 2 and K minus 4 are in SI base units, volts is not a SI base unit. Volts is a unit of what? Power. You will have to convert it into SI base units. Okay. So can I calculate the units of power? Yes. Force. Sorry. The power units are energy over time. Perfect. What will be the units of energy? kg m2 s minus 2. Okay. Divided by what is the unit of time? Seconds. This comes out to be kg m2 s minus 3 is your SI base units of watts. So instead of watts, you will write this thing, this entire thing, kg m2 s minus 3. Perfect. Let's write it. Kg m2 s minus 3. What else is left? Meter minus 2 and Kelvin minus 4. Perfect. What are the last units? The last units are of temperature. So Kelvin power 4. Perfect. Is anything getting cancelled out? Yes. Kelvin minus 4 and Kelvin plus 4 gets cancelled out. Simple. Meter square and meter minus 2 also gets cancelled out. Okay, perfect. This will become what? Meter square. This will, kg will remain kg s minus 3. Any answers like that? C should be your answer. Let me check the question. 34. 34 should have an answer of C. Yep. 34 has an answer of C. We are going correct. Let's move on to the next question. Okay, let's try out this question. At temperatures close to 0 Kelvin, the specific heat capacity C of a particular solid is given by this. And I'm really sorry for this blurry sort of images sometimes. Although they are not blurry, the scanning is slightly off. This is only a problem in the first few chapters. In the next chapters, it's pretty clear. Okay, so yeah, pardon me for that. And B is a constant characteristics of the solid. Okay, so what we are given, C is the specific heat capacity and T is the thermodynamic temperature and B is a constant characteristics of the solid. Okay, the specific heat capacity has units of this. Now here you notice a problem again. Again, your units of a specific heat capacity are not completely in SI base units. These units of a specific heat capacity are not completely in SI base units. This joule is not an SI base unit. This is a unit of energy. So what were the SI base units of energy? kg m2 s minus 2 kg minus 1 Kelvin minus 1. Instead of joules, I have placed what? kg m2 s minus 2. kg minus 1 comes directly downside. Kelvin minus 1 comes directly downside. Is there anything that is getting cancelled out? Yes. kg and kg minus 1 gets cancelled out. What will be your SI base units of a specific heat capacity? Meter square second minus 2 Kelvin minus 1. Simple as that. Okay. We have to calculate the SI base units of B. How will we do that? Pretty easy. C is equals to BT cube. Okay, perfect. What are the units of C? Meter square, second minus 2, Kelvin minus 1. B comes like this. What will be the units of temperature? Kelvin power 3. Bring Kelvin power 3 to the downside. M square seconds minus 2, Kelvin minus 1, Kelvin power 3 on the downside. This is your B. Let's bring Kelvin power 3 to the top side. Meter square S minus 2, Kelvin minus 4 is equals to your B. Any answers like that? B should be my answer. This is question number 35. Let's check out whether we are doing correct or not. Yes, 35 has an answer of B. Perfect. Let's further move ahead. Now, again, can you see this question? This question has been a part of the previous question. The units of a specific heat capacity are this. You have to calculate the SI base units of a specific heat capacity. What do you have to do? You have to replace joules with the units of energy. kg, m2, s minus 2, and kg minus 1, Kelvin minus 1. What will happen? This kg gets cancelled out. What are the units? m2, s minus 2, Kelvin minus 1. C is your answer. Which is this question? 40. 40 ka answer should be C. Let me see. Yeah. This is your answer. Perfectly fine. Let's further move ahead. Which list shows increasing lengths from beginning to end? Okay. Which list shows increasing lengths from beginning to end? Okay. So your length should be increasing from beginning to the end. Okay. So let's examine option 1. Initially, you have 10 raised to the power of minus 2, that is centimeters. Then you have 10 raised to the power of minus 9. Now, this is not your option. Let's see option B. Initially, you have micro, that is 10 raised to the power of minus 6. Then you have milli, that is 10 raised to the power of minus 3. Then you have nano somehow, that is 10 raised to the power of minus 9. Now, let's see option C. 10 raised to the power of minus 9, then 10 raised to the power of minus 6, then 10 raised to the power of minus 3, going good up till now, then 10 raised to the power of minus 2. C is your answer. In C, your length is getting bigger and bigger. Now, one confusion that students have is, sir, standard form mein number is decreasing. Always remember negative power, the smaller the negative power of 10 is, the greater is your number. You can write this as a key point as well. The smaller is the negative power of 10, the greater is your numbers. Let's try this out. The time taken for a satellite to orbit the Earth on a circular path is given by this equation, where r is the radius of the orbit, m is the mass of the Earth, and k is the constant. What are the SI base units of k? You have to calculate the SI base units of this innocent little quantity k. Time will have a units of what? S square. Okay, perfect. You have to calculate the units of K. What is R? R is the radius. Radius will have units of what? Meter cube. What is M? M is the mass. M will have the units of kg. Multiply kg to the other side. Kg second square. Bring meter to the downside. Meter cube is equals to K. Kg meter minus 3 S square is equals to your K. Any answers like that? I can see C as my answer. Which question is this? 45. Let's check this answer. 45 should have an answer of C. Yeah, C is your answer. Perfect. Let's further move ahead. Okay, let's try this out. The spring constant K of a coiled wire spring is given by this equation. Perfect. Wire R is the radius of the wire. Okay. Where R is the radius of the wire. Perfect. N is the number of turns and R is the radius of each turn of the wire. Perfect. The quantity G depends on the material from which the material is made. What is a suitable unit for G? Okay. We have to basically calculate the units of G first of all. Perfect. So K is a spring constant. So what are the units of a spring constant? We have already calculated that in this video. Force over extension is equals to your spring constant. What are the units of force? kg ms minus 2 divided by meters. Meter gets cancelled out. The units for spring constant are kg s minus 2. Perfect. We don't know the units of G. Okay. In the calculations, we will be ignoring R because R is what? A constant. And in the calculations, we will also be ignoring N because it has no definite unit. R is the number of turns. It has no unit. So we will be ignoring that as well. So K has a value of what? Kg S. Okay, so let me write it. The final unit equation will be something like this. K is equals to GR4 divided by R cube. K is what? K is Kg S minus 2. We have to calculate G. R has a units of meters power 4 and capital R has a units of meter power 3. This cancelled out. Meter comes to the downside. Kg S minus 2 divided by meter is equals to capital G. Kg M minus 1 S minus 2 is equals to your G. Now you have to see which one of this option is correct. Now to analyze which option is correct, you first of all need to know what is Newton equal to. What are the SI base units of Newton? The SI base units of Newton are the same as the units of force, kg ms minus 2. Okay. So if you place kg ms minus 2 here, let's check out option C. Kg ms minus 2 in place of what? Newtons and just a meter here. This will give you an answer of what? Kg m square s minus 2. This is not your answer. Your answer should come out to be this. Let's try out another option. Which option should we try? Let's try out option A. In option A, you have the units of Newton, that is kg ms minus 2 multiplied by meter minus 2. What will your final units become? Kg m minus 1 s minus 2. Yep, A is your answer. This has the same units as G. So 48's answer should be A. Yeah, 48 ka answer is A. We are going perfectly fine. Let's further move ahead. Let's see this. One property Q of a metal is used to describe the behavior of sound waves in the material. Q is defined as the pressure of the sound waves divided by the speed of the sound waves and the surface area of the material through which it travels. You have to calculate the SI base units of Q. Can you do that? Yes. Q is equals to pressure divided by velocity divided by area. Okay. Now, there, there is a little cheat code here that you can apply here. If you don't know the units of pressure, however, the units of pressure are pretty easy to calculate. Pressure is equals to force over area. Your units of force are what? Kg ms minus 2 divided by the units of area. This comes out to be what? Kg m minus 1 s minus 2. So, okay, so what will you do here? You will substitute the units of pressure that are kg m minus 1 s minus 2. What are the units of velocity? ms minus 1. What are the units of area? Meter square. Okay. Now let's simplify this. Kg m minus 1 s minus 2 divided by meter cube divided by s minus 1. Let's take meter cube to the top side. It will become kg m minus 4. And let's take second minus 1 to the top side as well. It will become second minus 1. Are there any options like that? C is your answer. Let me see the question number 49. The answer to 49 should be C. And yes, it is C. We are going good. Okay, so let's see this question as well. The diagram shows two coplanar forces, okay, P and Q drawn to scale. Perfect. Force R is given by this. R is equals to Q minus P. Okay. Which diagram represents R? Okay. So we have to calculate R and R is given by this formula Q minus P. Okay. So Q remains like this, but P reverses. Like if this is P, what will be negative P? Negative P will be something like this. So let's put a negative P here. Negative P. Can you analyze currently in this situation? We cannot calculate R. Why? Because the head to tail rule is not being satisfied. The tail of this vector Q is connected with this tail. Head to tail rule is not being satisfied. So we will bring this vector P to the negative P to the top side like this. something like this. This will become your negative p. Now head to tail rule is being applied. Perfect. The head of one vector is connected to the tail of the other vector. Can you mark the resultant vector now? Yes. The resultant vector is somewhat like this. This should be your R. Any options like that? C is your answer. I hope I am correct. 52's answer should be C. Yes, it is C. Perfect. Let's further move ahead to the next one. Let's see this. Again, here as well, you have to calculate the resultant force acting on the aircraft due to these two forces. Okay, we have to calculate the resultant force. Currently, if you analyze, this is the head of the first vector, this is the tail of the first vector, this is the head of the second vector, this is the tail of the second vector. Currently, both the tails are connected together. This doesn't satisfy head to tail rule. We will bring this vector towards the left hand side. Okay, like this. This is your head now, this is your tail now. This satisfies head to tail rule. Can I make the resultant vector here? Yes, somewhat like this. This is your resultant vector. C should be your answer. Which question is this? 53. The answer to 53 should be C. It is C. Perfect. We are going correct. Let's further move ahead. Okay, let's see this. Two forces, each of 10 Newton, act at a point P as shown. The angle between the directions of the forces is 120 degree. Okay, what is the magnitude of the resultant force? We have to calculate the resultant force. Again, if you ponder a bit, this is the head, this is the tail, this is the tail, this is the head. They are currently disobeying head to tail rule. So we will bring this vector to the top side like this. This is your 10 Newton vector towards the top side. If this angle is 120 degrees, this angle will become what? 60 degrees. Perfect. Now, can we mark the resultant? Yes. From the tail towards the head like this. This is your resultant which you have to calculate. Now, if you are a little smart, you will realize, that this is an equilateral triangle. This is 10 Newton, this is 10 Newton, the middle angle is 60 degree. This seems like an equilateral triangle. Sir, how do you know that? See, because if this is 10 Newton, the angle corresponding it will be, let's say, x. If this is 10 Newton, the angle corresponding it will be, let's say, x. The sum of angles in a triangle is what? 180. 60 plus x is equals to 180. X is equals to 60 degree. So this will also be 60 degree. This will also be 60 degree. If all the angles are same, it is an equilateral triangle. What is another property of equilateral triangle? All the sides are also same. So this resultant force will also be 10 Newton. B is your answer. Simple. Let's see this. If x is y minus z, which diagram represents vector z? First of all, make z the subject here. Take z to the left hand side. Z is equals to y minus x. Okay. So y will remain like this. X will become negative x like this. Somewhat like this. Now can you see currently head to tail rule is not being satisfied. This is the tail. This is the tail. Head to tail rule is not being satisfied. So what will we do? We will bring this vector y towards the downside. Like this. Oh, like this. This is your vector y. Now head to tail rule is being satisfied. This is the head. This is the tail. Yeah, that is being satisfied. Now you can draw the resultant vector from here till here. This is your resultant vector. Any options like that? A is your option. Let's check this as well. 55 answer should be A. Yes, it is A. We are going perfectly correct. Okay, let's see this question. A tennis ball is hit so that it leaves the racket with velocity v at an angle of theta to the horizontal. Okay. The vertical component of the velocity is vy. What is the magnitude of the horizontal component of velocity? Okay, so basically we have to calculate this horizontal component of velocity, let's say vx. And we are given that this is a right angle triangle with the vertical component being vy and this hypotenuse being v. If you are given the hypotenuse, if you are given the perpendicular, can you calculate the base? Yes, we will apply Pythagoras theorem. V square is equals to Vx square plus Vy square. Bring Vy square to the other side. V square minus Vy square taken under root is equals to your Vx. D is your answer. Simple. Okay, let's see this. What is the horizontal component of the force that is shown? Okay, we have to calculate the horizontal component of the force here. So basically we have to calculate this value. Okay. How will we do this? We will consider this as a right angle triangle. We will consider this as a right angle triangle. This is your hypotenuse of 20 Newton. This is your angle of 53 degrees. Can you calculate this base? Yes. Which ratio you will apply? Cos theta is equals to base over hypotenuse. Cos is what? Cos 53 multiplied by what is the hypotenuse? 20. What does your base come out to be? Let's calculate. 20 cos 53. This comes out to be 12 Newton as your answer. A is your answer. Simple. Let's further move ahead. Okay, let's see this. The diagram shows a force F. P is the horizontal component of F at an angle of theta to F. Perfect. Which graph best shows the variation with theta of the magnitude of P? Okay. We have to tell how does theta affect P. We have to tell how does theta affect P. Very, very easy. Can you see that F, P will be what? P will be equal to F cosine theta, just according to the right angle rule which I did in the previous question. Now, if your theta becomes 0, your P will be maximum. If your theta becomes 0, your P will be maximum due to the cosine graph, because cosine theta is 1 when theta is 0. And when theta is 90 degree, cosine theta equals to 0, P will become 0. So C and D will get cancelled out. The remaining options are A and D. Which one will you take? You will take option A, because you have to take something that resembles a cosine curve. A is your answer. 62's answer should be A. If I am correct, yes, it is A. Perfect. Let's further move ahead to the next questions. Okay, let's see this. Two cables are attached to a bracket and exert a force as shown. Okay. What are the magnitude of the horizontal and vertical components of the resultant of the two forces? Okay. We have to calculate the resultant horizontal force and the resultant vertical force. For this, we will have to resolve these diagonal forces. This 15 Newton force can resolve in two directions, one in horizontal like this and one in vertical like this. Perfect. And this 6 Newton force can also resolve in a horizontal direction like I should keep the colors same. This 6 Newton force will also get resolved like this and will also get resolved like this. Now let's write down the values of these forces. This red force will be equal to what? 15 cosine 20. This green force will be equal to what? 15 sine 20. Okay. This green force will be what? 6 cosine, 6 sine 40. 6 sine 40. This red force will be equal to what? 6 cosine 40. Now, which forces are in the vertical direction? This 15 sine 20 and 6 cosine 40 are in the vertical direction. And can you observe they are acting in opposite direction? One is acting upwards, one is acting downwards. So let's label the upward forces as positive, the downward forces as negative. So in the vertical direction, what will be your resultant force? 15 sine 20 minus 6 cosine 40. Can we calculate this? Yes, 15 sine 20 minus 6 cosine 40. This gives you an answer of 0.534. Okay. So B and D will get cancelled out. Either A is your option or C is your option. Now let's calculate in the horizontal direction. What are the forces acting in the horizontal direction? 15 cosine 20 and 6 sine 40. If you notice, both of them are in the same direction. We can say the forces acting towards the right are positive, the forces acting towards the left are negative. So the total force in the horizontal direction will be what? The total force in the horizontal direction will be what? 6 sine 40 plus 15 cosine 20. What will your answer come out to be? Plus 15 cosine 20. This comes out to be roughly 18. So C is your answer. Let's check your answer as well. 66 should have an answer of C. Yeah, that's it. Perfect. Let's further move ahead. Okay, let's see this. A particle travels in a straight line with a speed v. Okay, a particle is traveling with in a straight line with a speed v. Let's say somewhat like this. Perfect. The particle slows down and changes direction. The new speed of the particle is v over 2. Okay. The new velocity, which has a component in the same direction as the initial path of the particle, is v over 4, through which angle has the particle turned. Perfect. So, this is your initial speed, and after some time, your speed has changed in such a manner that in this direction, you are traveling with a speed of v over 4, and your total speed, let me mark that as well. Your total speed is what? V over 2. So by what angle have you turned? Can you calculate this? Yes, cosine theta is equals to base V over 4 divided by the hypotenuse V over 2. 2 comes to the top side. Theta is equals to cos inverse 2 over 4, which gives you an answer of what? Cos inverse 0.5 will give you an answer of 60 degree. Your answer should be 60 degree. Let's check out whether the answer of 69 is D. Yeah, correct, 60 degree. Perfect. Let's further move ahead. Okay, let's see this. The diagram shows an experiment to measure the force exerted on a ball by a horizontal airflow. Okay. The ball is suspended by a light string and weighs 0.15 Newton. Okay, so the weight is 0.15 Newton. Perfect. Let's zoom in a bit. The angle of deflection is 30 degree. What is the force on the ball from the airflow? Okay, we have to calculate this force on the ball from the airflow. First of all, if the ball is suspended from a string, what will happen? There will be a tension in here. Okay. And this tension will have two components, one horizontal like this and one vertical like this. The vertical component of tension, let's label this as TV and let's label this as TH. The vertical component of tension will balance out what? It will balance out weight. Perfect. What will TV be equal to? TV will be equal to tension cosine 30 is equals to 0.15. 0.15 divided by cosine 0.15 divided by cosine 30, your tension comes out to be 0.17. Tension is equals to 0.173 Newton. Also, if you are pretty specific about things, tension ka vertical component will act here, because vertical components and horizontal components act at the same point from where the actual force is acting. Now, sir, why have you calculated this? Because the horizontal component of tension is opposing what? Airflow. So you can calculate the force of air because it is equals to the horizontal component of tension. Simple. What will be the horizontal component of tension? A T, that is 0.173, and this will be what? Sine 30 is equals to your airflow multiplied by sine 30. This gives you an answer of 0.087b should be your answer. Which question is this? Let me see. This is 71. So 71 should have an answer of B. Here we have it. Perfect. Let's further move ahead. Okay, which we are given GM, TM, mu, M, PM, all units of length. Please remember gigameters means what? 10 raised to the power of 9. Terameters means what? 10 raised to the power of 12. Micrometers means what? 10 raised to the power of minus 6. Picometers means what? 10 raised to the power of minus 12. Which is the largest unit? Obviously, tera. Which is the smallest unit? Picometer. D is your answer. Simple. What is needed to represent accurately all physical quantities? Beta, what do we need to represent all physical quantities? A unit and a magnitude. C is your answer. Simple as that. You need a unit and a magnitude to represent all physical quantities. Let's further move ahead. Which row shows what all physical quantities must have? A magnitude and a unit. They don't need to have a direction. C is your answer. Okay, let's see this. Four cathode ray oscilloscopes, CRO screens, each display a waveform. The screen and the time-based setting of each CRO is shown. Perfect. Which screen shows waveforms of the same frequency? Okay, so let's zoom in a bit. We have to identify which screens show waveforms of the same frequency. If your frequency is to be same, your time period has to be same time period. Okay, if you analyze option A, one box represents what? 0.02 seconds. So the time period of this wave will become what? 0.04, 0.06 and 0.08. The time period of this wave becomes what? 0.08 seconds. Perfect. Let's try out option 2. This has a time based setting of 0.04 seconds per division. This is 0.04, this is 0.08. So the time period of the second CRO is also 0.08. So both of them represent the same frequency. 1 and 2. A is your answer. Let's see this. A cathode ray oscilloscope is used to display a waveform of frequency 2000 Hz. Okay. The display of the CRO is shown. What is the time based setting on the CRO? So if the frequency is 2000 Hz, what will be your time period? Time period will be 1 over 2000. This gives you an answer of, yeah, this gives you an answer of 5 into 10 raised to the power of minus 4 seconds. So time period is this 5 into 10 raised to the power of minus 4 seconds. Okay. If you express it in microseconds, okay, if you want to express it in microseconds, what will happen? It will become 500 into 10 raised to the power of minus 6 seconds. This becomes 500 microseconds. So these four boxes cover 500 microseconds. What will one box cover? 500 divided by 4. One box will cover 125 microseconds. A is your answer. 82's answer should be A. Let's see, let's find out. Yes, the answer for 82 is A. Simple as that. Let's further move ahead. A paperback book contains 210 sheets of paper. Its thickness is measured with a ruler as shown. Perfect. What is the average thickness of one sheet of paper in the block? Okay, so we have to calculate the average thickness of one sheet of paper. So let's see, where is the ruler starting. The ruler is starting at 0.9 centimeter and it is ending at 3.6 centimeter. Perfect. So 3.6 minus 0.9 divided by 210. 3.6 minus 0.9 divided by 210. This gives you an answer of what? 0.013 centimeters. This is your answer. Any answers like that? No, all the answers are in millimeters. So if I want to convert it into millimeters, I will take this decimal point one place forward. This will become 0.13 millimeter. C is your answer. Which question is this? 83. The answer to 83 should be C. Where is 83? Yeah, here we have it. The answer to 83 is C. Let's further move ahead. The diagram shows two readings taken from a micrometer. What is the difference between the two readings? Okay, now we have to calculate the difference between the two readings. Always remember your micrometers have two scales. One is the main scale, one is the thimble scale. This is the main scale and this is the thimble scale. I will tell you how to read both of them just in a minute. Okay. So on the main scale, each line represents 0.5 millimeter. Each line represents 0.5 millimeter. This is 0.5, this is 1, this is 1.5. So your main scale reading for this first micrometer is coming out to be what? Yep. 0, 0.5, 1, 1.5. The main scale reading for this first micrometer is 1.5 millimeter. Secondly, if you observe on the thimble scale, which line is getting aligned here with the main scale? Which line of the thimble scale is getting aligned with the main scale? This is 10, 11, 12. This is 12. So you will add, these are, okay, this reading, if you have 12 lines here, this reading is something like this 0.12 millimeter. So you will have to add the 0.12 millimeter in the main scale reading. What is your thimble scale reading? Thimble scale reading is 0.12 millimeter. Add both of them. Your total reading becomes what? Total reading is 1.5 plus 0.12 is equals to 1.62 millimeter. Simple as that. I am bringing all of this here. Perfect. So this is for your first micrometer. Let's observe for the next one. Okay. So here, this is 10, this is 10.5, this is 11, this is 11.5, this is 12, this is 12.5, this is 13. So the main scale reading is what? Main scale is giving you 13 millimeters. What will be your thimble scale reading? 45, 46. 46th line is aligning here. So the thimble scale is what? 0.46 millimeter, because this is the 46th line aligning here. What will be your total reading for the second ammeter? 13 plus 0.46. This comes out to be 13.46. Okay, so what will be the difference in readings? This is 1.62, the other one is 13.46 millimeters. Subtract both of them. 13.46 minus 1.62. Your answer comes out to be what? 13.46 minus 1.62. This comes out to be what? 11.84 is your answer. 11.84 is your answer. Are there any options like that? B is your answer. Which question is this? 85. Let's check out 85's answer is B. Perfect. You are going perfectly correct. Chalo. Let's further move ahead. Now, let's try out this question as well. A micrometer screw gauge is used to measure the diameter of a copper wire. Perfect. The reading with the wire in the position is shown in diagram 1. And when the wire is removed and the jaws of the micrometer are closed, the new reading is shown in diagram 2. Okay. So can you observe an interesting thing here? This micrometer has a zero error. When you have closed the jaws in diagram 2, still it is showing a reading. That means it has a zero error. And what is the value of that zero error? Can you see this thimble scale is aligning with the main scale at the 14th line? So what will be the thimble scale reading? What will be the thimble scale reading? 0.14 millimeter. This is your zero error. This is your zero error. Perfect. And this is a positive zero error. This is a positive zero error. What do you mean by positive zero errors, sir? Okay, let me give you a short lecture on zero errors here. So there are two types of zero errors: positive zero errors and negative zero errors. Negative zero errors. Positive zero errors overstate your values. Overstate your values. However, negative zero errors understate your values. Positive zero error should be subtracted from final result, from final result. And negative zero errors, as you might have guessed, should be added to the final result, to the final result. Simple as that. Okay. Now here we have a positive zero error because our zero, we basically have a reading beyond zero. Like the reading is not becoming zero when we close the jaws, it is becoming some positive value. That is known as a positive zero error. Perfect. Now if you go here, what is this reading? 0, 0.5, 1, 1.5, 2, 2.5. So the main scale reading is 2.5 millimeter. Okay. Where is the thimble scale aligning? At line 9. So the thimble scale reading will be 0.09. Total reading comes out to be what? Total is 2.59 millimeter. Okay. What was your zero error? 0.14. Subtract the zero error, 0.14. What will your answer come out to be? 2.45 millimeter. B is your answer. Let's see which question this is. This is 86. The answer to 86 is B. Perfect. We are going correct. Okay, let's do this micrometer question again. The diameter of a cylindrical metal rod is measured using a micrometer screw gauge. The diagram below shows an enlargement of the scale on the micrometer screw gauge when taking the measurement. Perfect. What is the cross sectional area of the rod? What a beautiful way to trick students. Beta, you are measuring the diameter with the micrometer. What will be the diameter here? 2, 2.5, 3, 3.5. The main scale is 3.5. What will be your thimble scale? Thimble scale is aligning at the 31st line. So the thimble scale will give you a reading of what? 0.31 millimeter. The diameter comes out to be what? 3.5 plus 0.31, that is 3.81 millimeter. You have to calculate the cross sectional area. How can you do that? Area is equals to pi over 4 du square, that is 3.81 whole square. Let's calculate it. 3.81 whole square into pi divided by 4. This gives you an answer of 11.4 millimeter square. This is your answer. Simple as that. Let's further move ahead. Very easy. The only trick in this question was to calculate the cross section area and not the diameter directly. Okay, let's see this question. A student takes measurements to determine the constant acceleration of a model car moving from rest in a straight line. Okay, so your initial velocity is 0. Perfect. The measured values with their absolute uncertainties are shown. Okay. The student uses this equation S is equals to half 8u square. Perfect. To calculate the acceleration of the car. What is the acceleration and its absolute uncertainty? Perfect, perfect, perfect. So first of all, utilizing this equation, S is equals to half a tu square. Can I calculate the acceleration? Yes, 2s over tu square is equals to your acceleration. Perfect. Let's calculate the acceleration first of all. What is your displacement? 16.5. What is your time? 15 square. What does your acceleration come out to be? 2 into 16.5 divided by 15 square. This gives you an answer of what? 0.15. Acceleration is 0.15 ms minus 2. That gets cleared out. Now we have to calculate the absolute uncertainty in acceleration. For this, you have to focus on this formula. To calculate the absolute uncertainty in acceleration, that is delta A, we can add up the fractional uncertainties of the variables given in this formula. The fractional uncertainty of acceleration is equals to the fractional uncertainty of displacement plus 2 times the fractional uncertainty of time. Why did I place a 2? Because time had a square power. Simple. Now you know everything here. You know acceleration, you know absolute uncertainty in displacement, you know the displacement values, you know the absolute uncertainty in time, you know the actual value of time. Can you calculate the absolute uncertainty in acceleration? That is this missing piece. Yes, you can do that. Let's multiply acceleration to the other side and let's calculate the answer. Delta A, or the absolute uncertainty in A, is equals to what? Is equals to acceleration, that is 0.15, multiplied by the change or the absolute uncertainty in displacement 0.1 divided by 16.5. Okay. Plus 2 times the absolute uncertainty in time divided by the total value of time. What does your uncertainty comes out to be? Uncertainty comes out to be 0.02. What will your final answer become? D, with an actual value of 0.15 and an uncertainty of 0.02. What is this question number? 103. The answer to 103 should be D. Where is 103? Yep, the answer to 103 is D. Simple. Let's further move ahead. Let's see this. Two measurements for a solid sphere are shown. The mass is this and the diameter is this. Perfect. These values are used to determine the density of the sphere. What is the percentage uncertainty in density? Perfect. So, what is the formula of density? Does anyone remember? Density is equals to mass over volume. Can I replace volume of a solid sphere with some formula? Yes. Volume of a solid sphere is equals to what? 4 over 3 pi r cube. And I also know that radius is diameter over 2. So let's replace it here. Density is equals to mass over 4 over 3 pi into diameter over 2 cube. Density comes out to be what? Mass over 4 over 3 pi diameter cube divided by 8. This becomes 1, this becomes 2. Your density is what? Mass over pi over 6. Yep, pi over 6 diameter cube. Can you realize that the only variables that are utilized in calculating density are mass and diameter cube? Pi over 6 is a constant. We will ignore that. Okay. So to calculate the percentage uncertainty in density, what can you do? You can calculate the percentage uncertainty in mass plus 3 times the percentage uncertainty of diameter. Why have I placed 3 here? Because diameter has a power of 3 on it. Simple. Okay, what is the percentage uncertainty of mass? 0.1 divided by 32.5 multiplied by 100. Plus what is the percentage uncertainty of diameter? 0.04 divided by 1.87 multiplied by 100. What will your answer come out to be? Let's calculate it. 0.1 into 100 divided by 32.5 plus 3 into 0.04 into 100 divided by 1.87. This comes out to be what? 6.72D should be your answer. Let's check out this question 106. The answer to 106 should be D, and it is D. We are on a 100% win rate today. Okay, let's see this. A spring is suspended from a fixed point and a force is applied. The position of a pointer attached to the bottom of the spring is adjusted against a vertical ruler, and against a vertical ruler is recorded. Perfect. Before the force is applied, the pointer is at this position. And after the force is applied, the position of the pointer is this. You are given the uncertainties as well. Can you calculate the extension of the spring? Yeah, extension of the spring can be easily determined 250 minus 225. Extension can be easily determined 250 minus 225. This comes out to be 25. Perfect. What is the percentage uncertainty in the extension? Always remember, whenever you are performing addition or subtraction, your absolute uncertainties get added up. 2 plus 2. What will be the uncertainty here in extension? 4. Can you calculate the percentage uncertainty? Yes. 4 divided by 25 into 100. This becomes 1. This becomes 4. 16% is your answer. Okay, let's see this again here. A micrometer screw gauge is used to measure the diameter of a wire. The reading on the ammeter with jaws closed is negative 0.05. This is a negative 0 error. And negative 0 errors are added. The reading with the wire in the position between the two jaws is plus 1.03. Okay. What is the diameter of the wire? We will take this reading, add 0.05 into it. So the diameter of the wire will 1.08, not C or A. Because in negative 0 errors, you add the quantity. Perfect. You add the 0 error basically. And what will be the uncertainty? I have always told you that whenever we are performing addition or subtraction, the uncertainties get added up. 0.02 plus 0.02, D is your answer. Simple. Let's also check it. This question is 1110. So 1110 has an answer of D. Perfect. Let's further move ahead. Okay, let's see this. A student measures the time for one complete oscillation of a pendulum of length L. Perfect. Her results are shown in the table. She uses this formula to calculate the acceleration of free fall of g. Perfect. So first of all, let's make acceleration of free fall the subject here. Take a square on both sides. Square on both sides. What will happen? It will become t square is equals to 4 pi square Lg. Perfect. Can we make g the subject here? Yes. G is equals to 4 pi square L over t square. Perfect. What is the best estimate of the percentage uncertainty of G? So the percentage uncertainty of G will be equal to what? Percentage uncertainty of L plus 2 times the percentage uncertainty of T. Perfect. What will be the percentage uncertainty of L? 0.001 divided by 0.42 into 100 plus 2 times what? 0.1 divided by 1.3 into 100. Can we calculate this answer? Yes, 0.001 divided by 0.42 into 100 plus 2 multiplied by zero point 0.1 into 100 divided by 1.3. This comes out to be what? 15.62. D is your answer. Simple. Okay, let's try this out. Okay, let's try this one out. In an experiment to determine the Young's modulus of a material of a wire, the measurements taken are shown. Okay. This mass is hung, this is the original length, this is the diameter. The Young's modulus can be calculated using this equation, where g is the acceleration of free fall. Perfectly fine. Okay. The calculated value of E is this. How should the calculated value of E and its uncertainty should be expressed? Perfect. So first of all, we have to calculate the uncertainty in E. The absolute uncertainty in Young's modulus divided by the Young's modulus is equals to what? The absolute uncertainty of mass divided by mass plus the absolute uncertainty of L divided by L. Now here, I have ignored 4 because this is a constant, and I have ignored G because this is also a constant. I will also ignore pi because this is a constant. Simple. Plus 2 times the absolute uncertainty in D divided by D. Why 2 times? Because there is a square. Plus absolute uncertainty of E divided by E. Okay. Multiply Young's modulus to the other side. What will your answer come out to be? Yes. What will your answer for this come out to be? Let's put the equations in the calculator. This is going to be a very hectic task. E has a value of what? 1.61 into 10 raised to the power of 10 into 10 raised to the power of 10. 1 second. E has a value of what? 1.6 into 10 raised to the power of 10. Okay. What is the value of the uncertainty in mass? 0.002 divided by 2.3. Perfect. Plus what is the uncertainty in length? 0.005. Please be careful while putting in the numbers. 2.864 plus 2 times what is the uncertainty in diameter? 0.01 divided by 0.82. Perfect. Plus the extensions ki uncertainty, that is plus 0.2 divided by 7.6. What will your answer for Young's modulus ki uncertainty come out to be? Yes, anyone in the chat. The answer for uncertainty comes out to be 0.09 into 10 raised to the power of 10. Any options like this? Yes, D is your answer. This was a pretty hectic question, so let's see it in the marking scheme. 120 has the answer of D. Perfect. One. So the answer is D. Let's check the marking scheme as well. 117 has an answer of D. Yes, this is question 117. It has an answer of D. Perfect. Let's further move ahead. Students take readings of the volume of a liquid using 3 different pieces of measuring equipment. Okay. X, Y, and Z. The true values of volume of the liquid is V. Perfect. The student's results are shown. Okay. Can you see X is accurate but not precise? Y is both. Y is not accurate but precise. How can I tell that? Because its values are concentrated at a center. Z is both precise and accurate. Number of precise experiments 1 to Y and Z. So A and B will get cancelled out. Number of accurate experiments X and Y. 2. D will be your answer. Simple as that. So this marks the end of the past papers for physical quantities and measurement techniques. If you have any questions, you may ask in the comments below.